Hello again. In this video, we are working through the last part of example 2 in section 8.1. We are writing out the terms of the sequences that are given and determining the limit of the sequence. So to begin with, the first part, writing out the first four terms of the sequence, that means that we are going to have -1 to the first power over 1, -1 squared over 2, -1 cubed over 3, and -1 to the fourth over 4. So this gives us -1 to the first is a -1. -1 squared is a +1, so that would be 1/2. -1 cubed is a -1, so that's going to be -1/3, and then a +1/4, and so on and so forth there. So there's our first four terms. Then to determine the limit of the sequence, we need to look at the limit as n goes to infinity of -1 to the n over n. And again, we are going to use theorem 2, which, if we scroll up to the notes from the previous video, theorem 2 says that the limit of the magnitude of the terms, if that's equal to 0, then that implies that the limit of the entire sequence is equal to 0. If it's not equal to 0, then the original sequence diverges. So because of the fact that we have this alternating sign term here, then it's going to be helpful to look at just the magnitude of the terms. So if we look at the magnitude here, notice this -1 to the n part just gives us positive and negative signs. So if we take the absolute value of that, it's all just going to become like 1. So we have the limit as n goes to infinity of just simply 1 over n. Now, the numerator is constant and the denominator goes to infinity. So if you think about denominators getting bigger and bigger and bigger, 1/4, 1/5, 1/6, 1/7, 1/100th, 1/1000th, so on and so forth, the terms are definitely going to 0. So we can simply conclude that that's equal to 0. So then by theorem 2, this is going to imply that the limit as n goes to infinity of -1 to the n over n is equal to 0. Okay, so that's our limit value, there's our terms, and that does conclude example 2.